Everything is fine. So we have these two options. Now note that the code here is largely the same as in the class decorator. So what is the difference between these two approaches? Formally, they seem to be very slightly different. It's different code in these two cases. But what's the consequence? Why might I choose one or the other? It's a very tricky question because we have to dig pretty deep. One, if we think about these two constructive approaches, we might think, to what degree do we have the ability to assert how the end user's code is laid out? Note that there is a difference in these two cases even as it stands, which is, in this latter case, derived is an instance of base, or sorry, it's a subclass here, and instances of derived are in fact instances of base. So here, let's do this. So both of these are met. Whereas here, there really is no established relationship here. This is not constrained. This is not an instance of constraint. Except the isInstance check is something that we can patch into quite readily. So nothing stops us, first, from doing the following. Like that. And then here, instead of doing isInstance, doing get adder of t constrained like this. So looking for an attribute that we have that's visible on this thing. We could even use build class to set this attribute to false everywhere else. That way we don't have to use get adder. We can just do t.constrained like that. So here we could use build class to set t.constrained equals false by default. But even if we think about the differences in the vocabulary here, we know that isInstance is part of the Python vocabulary to ask if an object is an instance of something. Here, let's call this base. Let's create a derived. Does not require that there actually be a pre-existing relationship. Here, note, derived doesn't actually come from base. It's misleadingly named. By default, there is no relationship between these. But all I have to do is add a metaclass to this thing. And in this metaclass, implement the Python vocabulary, specifically the Python vocabulary for checking if something's an instance. And this is the class and the instance. And there we go. And I think there's no underscore there. Very good. And now, anything is an instance of base, even 1, 2, 3, or ABC. So whether something is strictly an instance of something else using the isInstance vocabulary, well, there's a lot of flexibility there. This is just Python, part of the Python vocabulary that you can patch in whatever way that you want. There doesn't actually have to be a strict relationship. It is the case that you can't fake out the type call in Python. This is one thing that you can't fake. This is one thing you just cannot patch into. There's no way for us to say something like, I don't know, type equals whatever, and to give this a different answer than the actual type. We can patch out dir, but we can't patch out type, and we similarly can't patch out class. This is why in Python it's very difficult for us to create perfect proxies. So there are some limitations to this, and there are some code paths that we wouldn't be able to fake out, but at least for isInstance, really the distinction between the class decorator and the metaclass is quite minimal because we can always add in combination to the existence of this class decorator. We could easily add just a non-derivable type with a metaclass with an instance check implemented so that you could still say, you know, assert isInstance t constrained like that. And this would just require that we add something like this. So you get the general idea here that there really isn't that much of a difference between these two. So what else might the difference be? Well, note in these two examples, we get the fully constructed type. There is strictly a difference between the metaclass approach and the init subclass approach, or the metaclass approach and the class decorator approach. In that here, we get the type that was constructed. It's already been built, not the thing prior to being built. So we can't kind of patch into that thing. We can't swap things out. We can't as easily check what the body of what you define in here is. But that's fairly minor. There is, however, one important lingering difference. Although it's a difference that is quite interesting in terms of where we might observe it. Here, the presence of an inheritance hierarchy can have consequences to your end users. I actually think that asking your end users to use your given inheritance hierarchy has its problems. Because if you think about the way that the code is laid out, there's some base type, there's some derived type, and there may be multiple steps in between these. And there's some dividing line between the base type and the derived type in terms of where the library ends and where the package starts. If the library ends here and the application starts here, then enforcing your inheritance hierarchy is not such a big deal, in part because you seem to know way more about the code than the end user. You seem to have way more knowledge of the system or the underlying requirements of this system or of the problem that's being solved, and the user is really just kind of adding a little bit on top. So for them to inherit from you, not really any big deal, and for them to accept all of the consequences of inheritance, not really a big deal. If it's the case that the distinction between this is much shallower, let's say it's up here, then asking for a user to accept your inheritance hierarchy could be problematic, because it's clearly the case that you're adding a very small amount to this problem, and the end user is adding quite a bit to this problem. And so you could think that anything that you do in this base type that might cause, say, metaclass conflicts later, you could cause them trouble otherwise. So while I don't think the instance check, the isInstance stuff, is really that meaningful, it is the case that forcing an inheritance hierarchy onto somebody in some circumstances might be detrimental to their flexibility of what they want to do, especially if they own the majority of this hierarchy. In that case, I might say the the class decorator approach that you see in tools like data class is beneficial, because the thing with the class decorator approach is you just kind of patch the one class. You don't add to the inheritance hierarchy, so you don't introduce any of these. But the largest significant remaining difference between these two approaches, I think, comes down to modalities. Fundamentally, if we're talking about a decorator on, say, a function, well, a decorator on a function is basically the exact same thing as writing code in this formulation, which means if this decorator took some modalities, well, this is what we might call a high-order decorator. These two blocks of code are identical, and our decorator would look like this. So this would be like a create decorator or something. And here, this would give us our decorator, and this would return that. And here we have a simple pass-through, and then here these are our modal flags. Well, same thing exists on a class decorator as well. So if we think about this in the case of a class decorator, we're really just swapping out this function for a class, like this and this, like that. This thing now just takes a class, and we can provide modalities here. If we were to compare these two techniques, in the constraining case, if we had modes on this constraint, we could implement those modes like this. For example, maybe the constraint is generalized. The constraints are generalized in some fashion. For example, these are some checks that we have. And we could say, if not this check applied to this class, raise type error, whatever. Well, we can do the following. Like that. And we can parameterize the constraints. Whereas if we use the init subclass approach, there's really no way for us to parameterize these constraints, because if you think about how the init subclass approach looks, or even the metaclass approach, there are no keyword arguments here, except sort of there are, because when we implement this init subclass can take keyword arguments and positional arguments. And if we pass an argument here, like a mode, we can actually pick it up here. I'll show you. Let's quickly turn this off for a moment. There you go. Which means the modalities would have to occur in the class header as opposed to having to occur here. And there'd be some limitations to what modalities we can pass in. Obviously, there's reserved words. Metaclass means something here that it won't mean here. But fundamentally, you can think that there's a very, very tiny difference here. I would say that the use of modalities here probably are going to be some kind of unbounded modalities. They're probably going to be some kind of data modalities that give us some additional supplementary information about the class itself that might otherwise exist as a class method. And so they're not going to fundamentally distinguish between, two very different notions of how we might perform these constraints. Whereas in the case of the class decorator, I could see where in the class decorator we might have some bounded modalities here, which really do distinguish between fundamentally two different notions of what this constraining might look like. And the reason for that is, visually, the indication for what this means is this seems to indicate that this is not a modality on something that is being performed on class instantiation time. This is some additional supplementary information about the class itself. Therefore, whatever this information should be about the class itself. Therefore, the init subclass should operate based off of initializing any type of subclass, which should be relatively uniform, because what determines how that's initialized is really what the base class looks like. Whereas here, this visually indicates that these are parameters on the constraining mechanism, in which case you could imagine that those could be some sort of bounded modalities that indicate what kind of constraining to do, whether this is like an exception, raise an exception constraint, raise a warning constraint, whether you check this, this, and this, whether you also check that, whatever the case may be. That is a very, very subtle and very subjective difference, but it gives us a little bit of insight into the various approaches that we might take.